We're going to look at some theorems of algebra that are going to give us information about the zeros of the function. And from looking at the terms and the factors, we can find zeros. And when I say the word zeros, that means x values that make the expression equal to 0 when plugged in. It also translates on a graph to the x-intercepts. Okay, so by finding these zeros, it can help us figure out what a graph for the function should look like and where the function is equal to 0. So according to the fundamental theorem of algebra, how many zeros does the function f of x equals 3x cubed plus 2x squared minus x minus 1 have? Well, the fundamental theorem of algebra states that the degree of the polynomial tells us the number of zeros. So in this function, the degree is equal to 3, which means that there are 3 zeros. Done. And how do we know the degree is equal to 3? We look for the largest exponent. And in this function, that's a 3. Degree equals 3, then we have 3 zeros. Here we're asked to list the zeros for this function. Now this function is written in factored form. So we have 3 binomials that are being multiplied together. But we know from factoring that when we were asked to solve by factoring, that in order for this to equal 0, that means that just one of these would have to be 0. I mean, all of them could be, but at least one has to be. So we set each binomial equal to 0. And solve. Add 5 to both sides, and we get x equals 5. Subtract 3 from both sides, x equals negative 3. Add 11 to both sides, x equals 11. So those are our zeros. X equals, and we can write them in order, negative 3, 5, and 11, least to greatest. For this one, we're asked to find the remainder given f of x and then dividing it by x plus 2. Now, if you watched the previous lesson, we found remainders using synthetic division. So you have 2 options. When you see the words find the remainder, that means that you can either use synthetic division or your second option is substitution. So I'm going to show you both of those options for this problem. Let's look at synthetic division first. If I'm dividing by x plus 2, I set that equal to 0, and I find what x equals. So I would get that x equals negative 2. The negative 2 goes on the outside, and my coefficients go on the inside. My coefficients are 2, 3, negative 3, and 4. So 2, 3, negative 3, and 4. And actually the 4 isn't a coefficient, it's a constant. All right, so now I bring down the 2. I multiply negative 2 times positive 2 is negative 4. Add 3 plus negative 4 is negative 1. Multiply again, negative 2 times negative 1 is 2. Add negative 3 and 2 together to get negative 1. Multiply again, negative 2 times negative 1 is 2. And add. So that's my remainder. My remainder is 6 when I divide by negative 2. So now we can do the same thing or get the same answer by doing substitution. I'm going to substitute negative 2 into my function. So I'm going to have f of negative 2 equals 2 times negative 2 cubed plus 3 times 2 squared minus 3 times, negative 2, 3 times negative 2, and then plus 4. So let's simplify. This will give me 2 times negative 8 plus 3 times 4 minus 3 times negative 2 plus 4. So negative 16 plus 12 minus, or actually plus 6 plus 4. So now I just go from left to right. Negative 16 plus 12 is negative 4. And negative 4 plus 6 and then minus 4 gives me 6. So I think synthetic division is faster and easier, but know that you do have 2 options. When you're asked to find the remainder, in both options, you're going to have to first solve to get what x is going to equal. Set this equal to 0 and solve. And then you can either use synthetic division with that negative 2 on the outside, or you can use substitution and you can plug that negative 2 in for x. And regardless of which method you choose, you're going to get the same answer when looking for the remainder. So for this one, we're asked if x minus 2 is a factor. Well, we know that if it's only a factor if the remainder is 0. So I'm going to write that x minus 2 is a factor if and only if, which is what that means, the remainder is 0. And by saying if and only if, that means that I could also read this the other way. I could say if the remainder is 0, then we know that this is a factor. And if this is a factor, then the remainder is 0. By putting if and only if, that means it works both ways. It's bidirectional. Okay, so we have to figure out what the remainder is, right? We have 2 options. Our 2 options are, actually let me write this, remainder. That's what we're looking for. Because if the remainder is 0, that means it's a factor. So we have 2 options, synthetic division or substitution. So I'm going to use synthetic division. So x minus 2 equals 0 means x is equal to 2. So I'm going to put the 2 on the outside. I'm going to list my coefficients on the inside and my constant term. So I've got a 3, 5, negative 16, negative 12. Bring that down and multiply. 5 plus 6 is 11, and multiply. Negative 16 plus 22 is a positive 6, and multiply. And I get 0. My remainder is 0, so it is a factor. So the answer would be yes.